Okay, here are some questions on seismic waves, especially the body waves, the P waves, and the S waves. Let's take a look at number one. Base your answer to the following question on the diagram below, which shows models of two types of earthquake waves. Model A best represents the motion of earthquake waves called, and you have four choices there. If you'd like to, it would be a good idea to pause and see if you can answer the question, and then as soon as you're ready to hear the answer, just unpause. All right, we saw last time that there's a difference between P waves and S waves. P waves, the primary wave, S waves, the secondary waves, and we see that each of the choices here mention that, and every single one of them, each one is either Model A are called P waves, as we see in choices 1 and 2, or Model A are called S waves, that we see in choices 3 and 4. And then the other one is either called the S wave or the P wave. So the first thing to do is not get bogged down by all these words here. Either 1 and 2 are correct, that Model A represents the P wave, or 3 and 4 are correct, that Model A represents the S wave. And we mentioned before, and I think we even saw these diagrams, that P waves travel by pushing, that it's a compression wave. So Model A represents the P wave. So I automatically get rid of choices 3 and 4. Now let's see what's different about them. They both read P waves, compressional waves that travel. Now here's the first thing that's different, either faster or slower than the S waves. All right, so we either travel faster than, slower than the S waves or faster than the S waves. And we mentioned yesterday that the P waves are the first waves to get to seismic stations because they're faster. So we get rid of choice 2. The correct answer to this is number 1. How about this question here? Which statement concerning the demonstrated waves is correct? Again, if you'd like to pause now before the answer. So we see a very similar thing. We see very similar waves, wave A and wave B, and they ask us, what does wave A represent and what does wave B represent? And in this case, we see that the wave in A is traveling from point to point because of a pushing or a compression back and forth. So wave A represents the primary wave, and wave B represents the secondary wave. If we look at our choices there, the correct answer is number 1. All right, next question. Take a look. This, you'll need page 11 of your Earth Science reference tables to answer this question. All right, so they're telling us some information. They talk about a seismic station. It records some waves produced by an earthquake, and they tell us that that earthquake is 4,200 kilometers away. So they're letting us know the distance that the earthquake was, and approximately how long after the arrival of the P wave will the S wave arrive. So they're saying nothing's happened, and the P wave gets there, and they want to know how long after the P wave did the S wave show up. So they're saying that we get the P wave there, how much time elapsed before the S wave? Approximately how long after the arrival of the first P wave will the first S wave arrive? So we need to go and take a look at our reference tables and go to 4,200 kilometers. So here's page 11 of the reference tables. We mentioned this before, that down here at the bottom, this is 4,000. This is 5,000 times 10 to the third. So 4,200 would be right there at that spot. So the question asks about 4,200 kilometers away. So we're talking about this spot here. That's 4,200 kilometers right there. And what we could do is we could draw a line for that point right there. So 4,200, and we're talking about this area right there. And we notice that it hits the P wave, takes the P wave this long. All right, so if we went all the way across, took the P wave 7 minutes, and if that's 7 minutes here, this is 8 minutes here, we divide that up into 20 seconds apiece. 7 minutes, 20 seconds, 7 minutes, 40 seconds, 7 minutes, 60 seconds, or 8 minutes. So the P wave is at 7 minutes, 20 seconds. The S wave is right about here. We follow that all the way across. That's 13 minutes and 10 seconds. So all I got to do is take 13 minutes and 10 seconds and take away from that 7 minutes and 20 seconds. And that gets confusing. Sometimes if we try and subtract them, some people try and use their calculator, it doesn't work very well. What I like to show you is a good example to do, is to use the whole scrap paper method that we used before. So if we just grab ourselves a little piece of scrap paper, I'm going to draw a little piece of scrap paper here, and if we move that scrap paper right next to our line, remember we're going to put some marks on there. So here's the P wave, and right here is the S wave. What I can do is I can take my piece of scrap paper and I could just slide that down here to the bottom, the P wave, and we can see that they're about, whoa, excuse me, we can see that the P wave and the S wave are about 5 minutes and 50 seconds apart. Again, so let's take a look at the question. The question asks us approximately how long after the arrival of the first P wave will the first S wave arrive. So how much time is there in between the P wave and the S wave? And in this case right here, we see that's about 5 minutes and 50 seconds. About 5 minutes and 50 seconds. Also, if you want to, 5 minutes, 50 seconds, we could write it like that as well. All right, question number 4. Go ahead and take a look. Again, use your Earth Science reference tables. Pause if you'd like some extra time. The question asks us, again, how long after the arrival of the first P wave did the first S wave arrive? So a very similar question. We've got a P wave arriving, and then after a little bit of time is the S wave. It arrives, and the question is, how much time is that? We know that we got the P wave there, and we have the S wave at that point in time. How much time is in between them? And the distance, they don't give us the distance here, but they give us this information right here. All right, they say that the first S wave got there 11 minutes after the earthquake. So 11 minutes after the earthquake. See, the earthquake happened, and 11 minutes later, the S wave got there. Let's see what that looks like on our chart. So after the earthquake, 11 minutes later, the S wave gets there. So travel time is over here on the y-axis. All right, and what was the travel time of the S wave? Was 11 minutes. So we draw a line, 11 minutes to the S wave. So this is the point. So now we have our distance here. All right, we're talking about this distance at this spot. So if I move that on down, so 3,000, and I'm off a little bit. I should probably move my line over so it's just right on top of there. There we go. So 3,400 kilometers. So we're talking about that right there. Let's go back to the question. The question says, how long after the arrival of the first P wave did the first S wave get there? Well, I see when the first P wave, the P wave got here at this point in time. The S wave got there right there. So I can go over and look at the numbers and just kind of subtract those two. Some people, if you want, you know that this is 11 minutes. Here's 1 minute, 2 minutes, 3 minutes, 4 minutes, 4 minutes, 20 seconds, 4 minutes, 40 seconds. So about a 4 minute, 40 second difference. Or we could use the scrap paper method again, where we just take a little piece of, just as before, I put a mark for the P wave on that scrap paper, a mark for the S wave on the scrap paper. And if I slide that on down, how much time is there between the P wave and the S wave? You got about 4 minutes, 50 seconds. And so if I go back to that question, how much time? About 4 minutes and 50 seconds is the amount of time between the P wave and the S wave. All right, let's take a look at the next question. And this is something right off of the chart that we had drawn previously in the video. Which statement correctly compares seismic P waves with seismic S waves? And again, when we get a question that gives us all these different words and they're kind of lengthy choices to choose from, let's just look at the very beginning of some of them. So we're only going to look at just this part right here. All right. Or let me go back. So we should only look at this part right here. Let's ignore the second half. P waves travel faster than S waves are the first two, and P waves travel slower than S waves. All right, so we can automatically get rid of two of them without having to read through all of those choices right there. I know that P waves are the faster waves, so I don't even have to look at what else is written for choices 3 and 4. I know that that's the case. And now that I'm focused on 1 and 2, all I have to focus on is this section over here. I don't have to look at that. So P waves travel faster than S waves. I know that's true. And either they pass through the Earth's liquid zones or they do not pass through the Earth's liquid zones. And we mentioned in the previous video that P waves can travel through all states of matter. It's the S waves that can't travel through any liquid. So the correct answer here is number 1. All right, they can travel through all the different zones. All right, next question. Give this one a try. Again, page 11 of your reference tables. All right, in this case here, they tell us what time the P wave arrives. So if I draw this seismograph again, like that, I can see that the P wave is here, and they tell us that that P wave got to there at 12. All right, 12 noon, 12 midnight. It got there at 12. The P wave had traveled for 6,000 kilometers, they tell us. And they want to say, well, at what time did the S wave get there? Can you say what time the S wave got here? All right. Well, I know that it's 6,000 kilometers. The P wave traveled 6,000 kilometers from the earthquake. Remember, epicenter means where the earthquake happened. So let's find 6,000 kilometers. Here's our chart. I see that it traveled for 6,000 kilometers. That means the P wave right there, all right, that's when the P wave got there. It traveled 6,000 kilometers and got there at 12 noon. Well, look at this. What time did the S wave get there? Well, the S wave got there this much from here to here, this much time after the P wave. So if this is 12 noon, they said, what time is the S wave? Well, we could figure that out, again, by using the little, we could either slide all the way over and get the numbers and try and do some math work right there, or we could use that little piece of scrap paper, take the scrap paper and we put it right up against where the P wave and the S wave is, right along that line. So I've marked on here where the P wave is, where the S wave is, as well as the time. I take my scrap paper and I'm just going to move it on down here. And I can see that if the P wave was there at 12, the S wave got there about 7 minutes and 20 seconds later. So from the P wave to the S wave is 7 minutes and 20 seconds later. Well, I started it at exactly 12. So if I add 7 minutes and 20 seconds to 12, then I'm going to get a difference of, right, if this is from here to here is 7 minutes and 20 seconds, the time would be 12 o'clock, 7 minutes, and 20 seconds is what time the S wave got there. So if we look at the question, at what time will the first S wave arrive? The first S wave would arrive at 12:07:20. This question is related to how fast the P waves and the S waves travel. The seismograph recorded at station A would show. So station A right here, you notice, is closer to the epicenter than either stations B or C. Since it's closer, the P waves are going to get there first. The correct answer is 2, the earliest arrival of the P waves. All right, pause this and try figure this one out using your reference tables. So they tell us a little something about the P wave. They say the P wave takes 8 minutes and 20 seconds to travel from an epicenter to an earthquake. And their question is, well, if the P wave took 8 minutes and 20 seconds, well, how long did the S wave take to travel that same distance? So we go to our reference tables and we're going to find a P wave, 8 minutes and 20 seconds for the P wave. So remember, 8 minutes and 20 seconds would be right here, and the P wave, I know that the P wave must have been 5,000 kilometers away, and they're saying it's the same earthquake. So we just got to go up here and figure out, well, we'll head up a little bit higher there on the chart. We just got to figure out where the S wave hits this chart. So we come up right to here. There's the S wave, and we could just draw a line over and answer the question, how long did it take the S wave? It took the S wave 15 minutes. So we go back here, we can say the S wave was 15 minutes. Or if I wrote it the same way, exactly 15 minutes and 0 seconds. All right, last question. They're saying that a station is 4,000 kilometers from the epicenter of an earthquake, and we have the arrival time of the first P wave at 10 o'clock. So again, we draw, there's the P wave. So the P wave got there at 10 o'clock. What time did the S wave get there? The key is that it's 4,000 kilometers away. If I go to 4,000 kilometers right here, I can know the time difference between the P wave and the S wave. Again, I'm going to use my chart. I match up the P wave and the S wave. I see there's a 5 minute and 40 second difference.